All right, when we get done with this section, we will be able to navigate rather easily between a percent, decimal, and fraction. We'll be able to solve percent problems, word problems, be able to compute in percent increases and decreases, and evaluate the validity of claims based on percents. All right, what is a percent? Percent means per 100. A percent is a rate in mathematics. Anything that has the word per in it is called a rate. 50 miles per hour, 240 words per minute, 30 gallons per hour. All those are called rates in mathematics. All right. A percent is 1 per 100. Okay, percent means per 100. All right, so 1% is one out of 100. To change a percent to a decimal, what we do is we drop the percent sign and move the decimal point 2 places to the left. All right, 2 places to the left. We convert from a percent back to a fraction. We write the fraction with the percent in the numerator and 100 in the denominator, then simplify or reduce if necessary. So it's ultimately going to come down to remembering these things here. So from a percent to a decimal, the decimal point goes 2 places to the left. We drop our percent sign. All right, so we want to convert each of these percents to an equivalent decimal. To do that, we take the decimal point and we shift it 2 places to the left and drop the percent symbol. So 80%, with the decimal point understood to be right here, is going to have us move the decimal point 2 places to the left. And so it becomes 80 hundredths. That makes sense because 80 hundredths is 80 out of 100. And percent means per 100. So if you have 80%, you have 80 per 100. All right. 37.5%, 37.5%. Want to turn this into a decimal. This is not a decimal. This is a decimal percent. We want to turn it into an ordinary decimal. So the decimal point goes 2 places to the left as we drop our percent symbol. So as a decimal, it's 375 thousandths. That's now a decimal. 6% as a decimal. I believe that's isn't that the sales tax rate in this state here for purchasing non-food items? We pay Uncle Sam 6 cents on the dollar. So 6% means as a decimal, the decimal point is understood to be right here. It gets shifted 2 places to the left. So it's going to be 0.06. Makes sense because we interpret this as 600. 6 per 100 is better known as 6%. Any questions how we're converting a decimal to a percent? 2 places to the left decimal point, drop the percent symbol. All righty. Now how to go to fractional form? Well, 2 of these I've already shown you. 80%, we just drop the percent symbol, place 80 over 100 because percent means per 100. And this can be reduced down by 10 down to 8 tenths, which can be further reduced down by 4 down to 2 fifths. Down by 2. It can be reduced down by 2 down to 4 fifths. 6%, we put literally 6 over 100, drop the percent symbol and reduce. This reduces down by 2 down to 3/50ths, better known as 6/100ths. Okay. To turn 37.5% into a fraction, we first, what we can do is we can just put the number over 100 and drop the percent symbol. Because percent means 100 per 100. This really needs to be simplified, though. We don't like to leave a decimal or a fraction appearing in any numerator or denominator. So we would multiply the numerator of this by 10 and multiply the denominator by 10. Hence, my equivalent fraction would be 375 over 1,000. And now we can reduce 375 over 1,000. 5 will divide into both 375 and 1,000. 5 divides into 375 75 times, and divides into 1,000 200 times. Reducing by 5 again, we can reduce this down further to 15 over 40. Reducing by 5 again takes us down to 3/8. So 37.5% as a reduced fraction is 3/8. Any questions how I converted those percents to fractions and then reduced? So whenever you have a percent, you just drop a percent symbol, place the number over 100, and then reduce it or simplify it. That's all you do. So now we know how to go from a percent to a decimal and also from a percent to a fraction. Questions? All right, so they're illustrating what I just went over. All right, to change a decimal to a percent, we move the decimal point 2 places to the right and attach the percent symbol. To change a fraction to a percent, we first change the fraction to its equivalent decimal form by dividing the numerator by the denominator, and then change the decimal to a percent. So let's see what that entails. They want you to convert each of these to a percent. All right, so how do we convert this decimal 472 thousandths into a percent? We shift the decimal point 2 places to the right. And then we drop, when we add the percent symbol. So this will be 47.2%. Decimal point goes 2 places to the right. Change a decimal to a percent. 1.03, what would be as a percent? We're going to move the decimal point 2 places to the right. So this is going to be 103%. Makes sense, because if you got one whole of anything, you have 100% of it. And if you got 3/100ths more of that something, you got 3 extra percent of that something. So 100% plus 3% is 103%. All right, what would be 7/8 as a percent? First, you want to turn 7/8 into a decimal by dividing the numerator by the denominator. You get this decimal, 875 thousandths, and then you shift the decimal point 2 places to the right, and you attach the percent symbol. So 7/8 is equivalent to 87.5%. So if you consume 7 of 8 pieces of an entire pizza, you have consumed 87.5% of that pizza. 5/6, what would that be as a percent? First, turn 5/6 into a decimal by dividing 5 by 6. We discover that we get a repeating decimal. 0.83333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333. That 3 goes on forever. How do we convert that into a percent? We shift the decimal point 2 places to the right and attach the percent symbol. Now, this 3 goes on forever. So you're gonna have to make a decision where you want to round and where you want to truncate this thing here and round it off. But it would be 8.83.33333333333% if you leave it in exact form. Or like I said, you could choose to round it off somewhere. All right, any questions how we're converting decimals to percents or how we're converting fractions to percents? All right. The most common calculation involving percent word problems is finding the percentage of some quantity. For instance, if you want to find 50% of 10, how would you do that? Well, in word problems, the word of means multiplied. Of means multiplied. So if you want to take 50% of 10, you turn the percent into a decimal first by shifting the decimal point 2 places to the left, dropping the percent symbol, and then you multiply that decimal by 10. So 50% of 10 is 0.5 times 10 or 5. How much of one whole is 50% of that one whole? If you've consumed 50% of a pizza, you've eaten what fraction of a pizza? What do you
Half.
One half. One half. If you consumed 100% of a pizza, what fraction of the pizza did you consume?
Whole thing.
The whole thing. If you consumed 25% of a pizza, what fraction of one whole pizza did you consume?
1/4.
1/4. If you consume 75% of a pizza, you've consumed
3/4.
3/4 of the pizza. Making sense here, Legend? Okay. So 50% of something is half of that something. There's no surprise then that we get 5 when we take 50% of 10, because half of 10 is 5. Okay. So when you take the percent of a number, you can kind of like check your answer for reasonableness when you get done. Here's an example. According to a nursingcenter.com, about 9.6% of all registered nurses in the United States are men. The average hospital in 2020 had 284 registered nurses. How many would likely be male? How are we going to answer this question, gentlemen? I'm going to take what? 9.6 what? Percent of how many registered nurses in 2020 average in each hospital? 284. Now, how do you take 9.6% of 284? First, you change the percent to a decimal, shift the decimal point 2 places to the left, which gives you 0.096. Drop the percent symbol, and then of means multiply. So then you multiply this by 284. Get on your calculator and dial that up, you got your answer. So 0.096 times 284.
You take that closer, it feels like, well, I guess it is.
Gives you about what? On average, about 27 of the 284 nurses in each hospital are male. Okay, makes sense how we did it, problem there. Okay. Another example. My wife is an absolute wizard with Macy's coupons. Wishful thinking. As a high volume shopper there, she gets quite a few coupons in the mail. On one recent mall outing, she found a lovely red strapless number with a selling price of $79. She had 2 coupons to choose from. One offers $15 off any purchase of $50 or more, and the other offers 20% off any item. Which was the better choice? How much did the dress cost? The sales tax in our country is 6.5%. Wait, in our county is 6.5%. What was the total cost, including the sales tax? All right, ladies and gentlemen, what was the better buy here, the better deal? Well, let's analyze each one individually. Is a $15 discount the way to go? Well, now, they're asking the question, 15 is what percent of $79? So what they did is they set up an equation by translating these words into an equation. 15, the word is means the equal sign. What means unknown? So what percent means the percent is unknown, they call it X. Of means multiply, 79. So we really have to solve this equation for X, so we divide both sides by 79. And we get 1900s. And so there's a $15 discount is only basically what? It's only 19% off, correct? So the 20% off would probably be slightly a better deal here. That makes sense, sir? 20% off is a little bit better than the 19% off, which is the $15 discount. Now, if you're in the store and you don't have any calculator, which is usually the case, how could you do this like mentally on the fly? What would be 20% of 79? Now there's that one. Let's just round 79 up to about $80. Make our calculations easier. Look, you don't need a calculator here. All right, what's 2 times 8? 2 times 8 gives you 16, correct? So 20% of 80 is what? $16. So that's $16 off. Do you agree that's a little better than $15 off? Okay. Not by much, but it is. So we just guesstimated this in our minds without using a calculator. See how I did that? I bumped 79 up to 80 to ease the calculation burden. 20% of 80, I just took 2 times 80, $16 off. So actually, in reality, 20% of $79 is $15.80. You know, that's pretty darn close to my $16 guesstimation, isn't it? As I estimated it on the fly. Pretty close, right? So by taking the 20% off coupon and applying that, as opposed to the $15 discount coupon, it looks like you do save a little bit of money, correct? You save what? 80 cents. Now, you know, we could argue that either way, whether that's significant. Some of you might think, well, on the way home, I could probably find more in bottles and cans along the road to cover that. You agree? But ladies and gentlemen, nonetheless, 80 cents is 80 cents. There's different ways of looking at it. Any questions about that problem? Now we want to find 6.5% of the sale price, which is what? Well, after we knock off $15.80 off $79, the sale price is $63.20. Now we need to assess the sales tax, which is 6.5%. So therefore, we're going to find out what 6.5% of $63.20 is by dropping our percent symbol, changing 6.5 to a decimal, moving a decimal point 2 places to the left. We have 0.065, and then we multiply by $63.20. And we discover that they're going to assess us an extra $4.11 for sales tax. So the price we pay at the register is the sale price, which is $63.20, plus the sales tax, which is $4.11. We'll pay $67.31. Is there that item? Now, another way we could have done this problem is this a way, a slightly quicker way that we could have maybe entertained or done this problem here. We could have realized this. The final price is going to be 100% of sale price plus 6.5% of sale price. Because they're going to tack on 6.5% sales tax. You see that there? Which is to say, ladies and gentlemen, that the final price is going to be 100% plus 6.5% of sale price. Which is to say it's going to be 106.5% of the sale price. Is this making any sense here? Which is equal to, how do you take 106.5% of the sale price? Change the percent to a decimal by shifting decimal point 2 places to the left, so that's 1.065, and then you multiply it by the sale price, which is $63 rather, and 20 cents. And when you do that, ladies and gentlemen, multiply $63.20 by 1.065, you're going to have $67.31. That's the final price you pay. So there's different ways of looking at this. Do you agree? Whether you want to do it with 2 steps. Step number 1, find the amount of sales tax we owe. And step number 2, actually adding the sales tax to the sale price. Or if you just do it all in one swoop, one swoop, realizing that the final price we pay at the register is going to be 106.5% of the sale price. Because that's 100% of the original sale price we know we owe, plus we know we owe an additional 6.5% of the sale price in sales tax. This is quicker. This only involves 1 step as opposed to 2 steps. All right, another example. A medium-sized company reported that it had to cut its workforce back to 70% of what it was last year. If it has 63 workers now, how many did it have a year ago? Well, one way to look at this problem is to ask yourself this question. Is our workforce going to be larger today than it was last year? Or smaller? What do you think? Anybody?
Smaller.
Smaller, because we had to cut back. In fact, our workforce today, now this is one way to do the problem. The workforce today is equal to only 70% of the workforce last year. So to compute the workforce today, we take 70% of the workforce last year. Now, do we know the workforce last year? No. In fact, that's what they're asking us for. What was the workforce last year? So change the percent to a decimal, 0.70, drop the percent symbol, and we're going to multiply this by the workforce last year. Now, ladies and gentlemen, we don't know the workforce last year. We could give it a variable name, call it X. What's the workforce today, though? They tell us it's 63. So we have an equation. 63 is equal to 0.70 times X. How do we solve for X? How do we solve this equation for X? We're going to divide 63 by 0.70, and that would be equal to X, which is the workforce last year. So take 63 and divide it by 0.70, and you get the workforce last year was 90. So this implies that the workforce was 90 last year. That's one way to do the problem. Okay. So that's one way, that we could have done the problem. Everybody see that there? That works. Okay. Does anybody want to see another way of doing this problem?
Sure.
Method 2. First of all, you could take the workforce last year, which is X. We don't know what it is. Then you can subtract off 30% of X because they're cutting back by 30%. That must be equal to the workforce today. Here's another way to do the problem. Now we're going to solve this equation for X. But what's 1? Notice you got 1 in front of X here. What's 1X minus 0.30X as we combine these like terms? What's 1 minus 0.30? Doesn't that give you 0.70? And ladies and gentlemen, aren't we back with the same equation that we just solved above? X is equal to X is equal to 63 divided by 0.70, which is 90. So that's a slightly maybe different way of looking at it. Both ways work. Both ways work. All right, any other questions about this problem? Another example, a real estate agent receives a 7% commission on all home sales. How expensive was a home if the commission received was $5,775? All right. Commission, ladies and gentlemen. Commission is popular in the real estate industry. If you've ever done any waitressing or waitering at a restaurant, in a way you do receive a commission also in the form of what are called tips. Okay? Tips are not exactly what commissions are, but it's something that's earned above and beyond maybe your hourly salary or maybe your annual salary or monthly salary. Okay? So, how would we compute a commission? Well, commission earned is always equal to the commission rate times the amount of sales. So the more you sell, the more commission you're going to earn. The greater the commission rate, the greater commission you're going to earn. Our commission rate initially comes at us in the form of a percent, which will have to be converted into a decimal before you incorporate it into this equation. All right, now let's see, using this commission equation, if you will, where would the $5,775 go? Do I substitute that in for the commission earned, the commission rate, or the amount of sales? What do you think? Where does that go?
Commission earned.
They tell us that's the amount of commission that's earned. So therefore, this $5,775 is going to occupy the left side of this equation. The commission rate is 7%, but 7% as a decimal is 0.07 times, but ladies and gentlemen, they want to know how expensive was a home sold, how expensive was the home that was sold to earn a $5,775 commission. We don't know what the price of that home was, so we'll call it X. Give it a variable name. We have to solve this equation for X. To do that, we divide both sides by 0.07. And that gives us X. So now we get on our calculator and dial that up. So 5775 divided by 0.07 means that the home we sold was valued at 82,500. This was the value of the home that was sold. There's your answer. Did that problem make any sense, sir? Commission? Furniture salespeople earn a commission too. That's why when you break the door of a furniture store, it's like you're this huge magnet, and these salespeople are like iron filings, ladies and gentlemen. As soon as you break the plane of that door, they all flock to you. Do you agree? Because they know they can sell you that sofa over there. They're going to make a commission. Do you agree? All righty. Now, don't get me wrong. If you have a job, that earns a commission, you're going to have good days and you're going to have slow days too, though. For that reason, because you have, good days and you have bad days as far as selling things are concerned. Most salespeople also earn a salary above and beyond their commission, which is a good thing because a salary is a guaranteed income. You see, commission is not always a guaranteed income. It's great. It's great if you, make a commission, if you have a good day, but, you're not always going to have a good day. So it's good to earn a salary, also with a commission. Okay. Any questions about this commission problem here? All righty. Now, I have to clear my writing before I move to the next slide, because if I don't, the writing will come along into the next slide. That's just the way my computer screen's working here with this application. So I got to get rid of this, but it's on the video. It's being recorded. There's the solution. All right, now, suppose, ladies and gentlemen, we want to find the amount of increase or decrease. Or we want to compute what is called the percent increase or percent decrease between a starting number and a final number. Well, we have a little formula here that can help us out. What we do is, first of all, we compute the amount of increase and we divide by the original amount. That'll give us a decimal. Well, no, they leave it as a fraction, excuse me. And then you change the fraction to a decimal by literally dividing the amount of increase by the original amount. And then you turn a decimal into a percent by shifting this decimal point 2 places to the right and adding the percent symbol. Or what if we have a decrease? To compute the percent decrease, we would take the amount of decrease and divide it by the original amount. That'll give us a decimal. And then we just convert the decimal to a percent, and we'll have the percent decrease. Let's see how these things work here. All right, here's an example. A municipal government promises voters that there will be a 15% cut in spending for the next fiscal year. Does anybody know what a fiscal year is in the business world? A fiscal year. What's a fiscal year? Our years go from January 1st to what? December 31st. You agree? Our regular calendar year. Well, what's a fiscal year in the business world? Anybody know what a fiscal year is? What the dates are for a fiscal year? It's not January 1st to December 31st. That's not a fiscal year. Nobody knows?
I don't know the exact dates, but I know it's when I think it's more or less when companies keep their balance for the year. They divide things by quarterly shifts.
All right. Yeah, and a lot of companies probably operate that way. A fiscal year starts on July 1st, ladies and gentlemen, and it runs all the way to June 30th. So July 1st to June 30th is a fiscal year in the business world. July 1st to June 30th. And there's a lot of things that are kept track of on a fiscal basis, not on the calendar basis. For instance, my pay, ladies and gentlemen, as far as the points I earn towards my retirement, is based on the fiscal year. It's not based on the calendar year. Okay. And it might be for years too. But don't get me wrong, a fiscal year is the same length as a regular calendar year. It's just that it starts and ends at a different time. That's all. All right, here we go. The city's budget was $72.5 million this past year and is projected to be $64.3 million for this year. Is the government keeping its promise? Well, we'll find out. Hey, before we find that out, Liz, I got another question for you here. So there's a lot of learning things in this problem here that I want to just convey to you, give you a little extra for your money here. 72.5 million. What does that mean when I say 72.5 million? Can we just convert that into a regular number? How would we write this as a regular number in decimal form? When we say 72.5 million, what does that really say? Well, it's saying 72,500,000 what? 500,000. That's 72.5 million. It's 72,500,000. And 64.3 million. What's that going to be? 64.3 million. That's going to be 64,300,000. Okay, just thought I'd throw that out to you. If you've never seen that before, now you've seen that. That's what it means. So that's good to see this. I mean, it doesn't hurt intellectually. If you already knew that, great. But if you didn't, hey, we learned something. All right, ladies and gentlemen, is this government keeping their promise? Remember, they promised a 15% cut in spending, correct? Let's find out. Now, here's what we got. Here's how we have to do these problems here. Our original number is 72.5 million. That's our original number. Or, ladies and gentlemen, for the sake of, oh, I'll show you that in a second. That's our original number. Our final number is what? 64.3 million. That's our final number. There definitely was a decrease in the budget. Let's find out what percent. So we're going to compute a percent of decrease. Here's how we do it. And then what we're going to do is we're always going to take the big number and subtract off the small number. And we're going to always divide that by the original number. Then we're going to multiply this whole thing by 100%. Now, here's the beauty of this formula that I gave you, contrary to what they gave you on the previous slide over there. My formula is more robust because my formula, ladies and gentlemen, will work for not only a percent of decrease, but it will also work for a percent increase. It also works for a percent increase. So this formula works not only for a percent decrease, but also for a percent decrease. Yeah, works for both. So let's follow along here. Percent decrease. What's my big number? 72.5 million. Now, I don't even have to put the word million in there because both these numbers are in terms of millions. So this is drop off the millions. We know it's in millions. 72.5 minus the small number is 64.3. With the understanding, of course, that those are in millions. We're going to divide this by the original number. What is my original number? 72.5? Get on your calculator, ladies and gentlemen, dial this up. Make sure you can do this on your calculator. Oh, you might want to enclose that numerator inside parentheses, otherwise you're going to get a logical error. All right, so how would we do this on our calculator here? Well, I will show you on the calculator, this calculator that does have parentheses on it. I can't bring it up on the screen, unfortunately. But I can show you underneath my camera here. All right, so here's my calculator. And let's see if you can see it here. Okay. So I'm going to start off with an open parenthesis. And what was it? 72.5 million? Was that it or not? Oh. 72.5, 64.3. Okay. So I'm going to type in 72.5, subtract 64.3, divided by the original number, which is 72. Wait a minute, should be divided by the original number, which is 72.5. And then, ladies and gentlemen, I'm going to multiply this by 100% at the end. Everybody see how I type that in there? And that gives me 11.3% what? Decrease in spending. Everybody see that there? How I did that? Okay. So again, I took 72.5 minus 64.3. Now I divided that by 72.5 and then multiplied it by 100. 11.3% decrease in spending. All right. Did the government keep their promise, ladies and gentlemen? Well, they said it was going to be a 15% decrease. Do you agree? It was only 11.3%. So looks like they reneged there. They did not keep their promise. Now, on this PowerPoint presentation here, they're taking 64.3 and subtracting off 72.5. You get a negative number, and a negative indicates it's a decrease. But later on, we know it's a decrease. We can clearly see we're going from 72.5 to 64.3. We're going from $72.5 million down to 64.3 million. We know that's a decrease. We can see it. So again, I would recommend that if you want a more robust formula that will compute percent increase or decrease, you can always use my formula, which we always take the big number, subtract off the small number, and divide it by the original number. The original number is the starting number, okay, the number you start with. In this case, our original number, or the number we start with, is 72.5. That's called our original number. And then you just multiply this by what? 100%. That will compute a percent increase or a percent decrease if you use that formula all the time. Easier to remember. Big number minus small number divided by original number times 100%. So this is your original number times 100%. There you go. All right, so like I said, ladies and gentlemen, you can jot that down, or like I said, this is being recorded, so you can, jot that down in the future there. That's a more robust formula to be computing in percent increase or decrease. Works for both. Just remember your original number is always your starting number, though. That's something you got to remember. The original number is always this number here. So let's see if we can use this formula to do this problem here. Suppose I went from 60 to 80. Is this an increase or decrease? 60 to 80. What do you think?
Increase.
Increase. All right, use my formula now to compute the percent increase in going from 60 to 80. Everybody do this. I want you to compute the percent increase in going from 60 to 80 using my formula. Go ahead. All right, did we get 33.333333% increase? By using my formula there. Notice 60 is the original number. It's the starting number here. Did we get that? Anybody?
Yes.
What would be the amount of increase? What would be the amount of increase? The percent of increase is 33.3%. What's the amount of increase? The amount of increase is equal to 80 minus 60, which is 20. The amount of increase is 20. The percent of increase is 33.3%. Back over here for this problem. What's the amount of decrease? The amount of decrease is 72, is going to be 72.5 minus what? 64.3. That's the amount of decrease. Which is going to be equal to what? 8.2. That's the amount of increase. Okay. Do we understand amount of increase, how to compute the amount of increase or amount of decrease? And then a percent of the decrease or percent of increase now? Between two numbers. So my formula, again, ladies and gentlemen, is more robust than what they got on this PowerPoint here. It'll handle any percent increase or decrease problem there. So, all right, let's see if we can move on. Now, you got to be careful with percents involving multiple steps of a word problem or multiple deductions, if you will. It can be misleading. Here's a classic example to illustrate the deception that retailers could subject you to. A department store advertised that certain merchandise was reduced 25%. Also, an additional 10% discount card would be given for the first 200 people who entered the store on a specific day. The advertisement, therefore, would state that this amounted to a 35% reduction in the price of an item. Is this advertisement being honest here? We'll find out. Now notice they took 25% and added on 10%, and they call it 35% total reduction, correct? Let's find out. Let's say, ladies and gentlemen, an item is originally priced at $50. It doesn't matter. You can use any price, starting price for the item. First, let's find the 25% discount. Discount, the amount of money that's taken off of an item is equal to the discount rate times the selling price. The discount rate is 25%, which will have to be turned into a decimal of 0.25, as we then multiply it by the selling price of $50. So it looks like they're going to knock off $12.50. That's the discount. That's the 25% off. So if you take $50 and subtract off $12.50, your price is down to $37.50. But, ladies and gentlemen, they're going to knock off an extra 10%. 10% of the reduced price. So what amount of discount do we take off of the $37.50? That's going to be 10% of $37.50, which is 0.10. They did not show the step here, but you'd have to turn the percent to a decimal again, 0.10, and then you multiply it by the $37.50. And they're going to take off an additional $3.75. Okay, fair enough so far. So now we got our price down by $3.75 more, which takes it down to $33.75. All right, remember we started with a $50 item. We got it all the way down to $33.75 after they took 25% off and also give us an extra 10% off. Let's find the percent of the total reduction. The final amount is what? In other words, how much off did they really do? How much off did we really take off, take away from the $50 here? $50 minus $33.75, we took off $16.25 totally. If you divide that amount of decrease by the original amount, which was $50, our starting price, and multiply by 100%, ladies and gentlemen, you basically obtain this. The fact that from the $50, ultimately, they really took off 32.5%. Notice that's not 35% off, though. A little misleading there. You see that? A little misleading. So, because we're taking percents off of numbers that are being reduced by previous percents off, okay, it's not as simple as just adding 25% to 10%, calling it 35% off total. It's more, it's a little less than that. It's like 32.5% off of the $50 is what we really are experiencing here. Okay. So that's a situation where, you know, it could get a little bit murky when you have multiple discounts, but the discounts are being applied in, how shall I say it, stages. Okay. More than one stage. In other words, you're not taking a total percent off of the original price. You're taking a percent off of one price, and then that price then is subjected to another discount, which might be subjected to another discount thereafter, et cetera, et cetera. So it's not equivalent to just summing up the original percentages and taking that percent off the original price. So I just want to point out here that it can be a little bit misleading with these multiple discounts here. All right. If you take the discounts off in stages, or if you add all the discounts together and then take it off the original price, there is a difference here, what we're finding out. All right, let's go to our textbook and see if we can have some fun now. Working with some percent problems, okay? And this will be section 7.1. And as always, you know, if you got some extra time, it's always good maybe just to kind of look through these sections here. Ladies and gentlemen, there might be some other examples that they're exposing you to throughout the section, which can give you different looks, okay? And some of these look like some of the examples that were on our PowerPoint, though. Do you agree? It looks like that example in the real estate example. Huh. All right. Okay. All right. Let's see if we can try a couple out here. These are just changing percents to decimals and decimals to percents. And let's see here. All right. I'll have you do just maybe a couple here. All right, number 23. We're going to open up a running tab on classwork 1, ladies and gentlemen. I want you to do 23 now. I want you to convert that percent, that decimal percent, into a decimal. Convert 62.5% into an ordinary decimal. Number 23. I'll give you about 30 seconds to do that. Go ahead. All right, so 62.5%, we're going to turn into a decimal, shift decimal point 2 places left, drop percent symbol. So it's going to be 0.625. We good on that? All right, how about a percent to a decimal now? Do problem number 29. Convert 24% into a decimal. Well, that's the same thing we're doing up here. All right, hold on a second. Hold on a second. Now I want you to do number 27. Number 27, convert 66 2/3% into an ordinary decimal. Go ahead and do that problem. 66 2/3% into a decimal. All right, so one way to do this is to first convert this mixed number percent into an improper fractional percent. Multiplying 66 times 3 and adding 2 to that, placing it over 3, that's 200 thirds percent. Then what you can do is turn this into a decimal percent by dividing 200 by 3. That gives you 66.66666666%. Then dropping the percent symbol, shifting decimal point 2 places to the left. That gives you 0.6666666666 as a decimal. Did anybody get that? That's
I
one.
got it.
So that'll work. All right. All right. All right, try 33. 0.5% would be what as an ordinary decimal? 0.5%. Convert that to a decimal. All right, so you can convert 0.5%, first of all, into a decimal percent by dividing 1 by 2. It's really 0.5%. Then you can drop your percent symbol, shift your decimal point 2 places to the left, and now you have an ordinary decimal, 0.005 or 5/1000ths. Did anybody get that there?
Yes.
Let's see. All right. So what we did was you convert that into a decimal. Now, how could we convert this into a fraction? We wanted to convert this into a fraction.
Move it 2 places to the left. I mean to the right.
No, hold on,
No.
careful here. We don't want it as a fractional percent. We want to just represent it as an ordinary fraction. Tell you what, how do we read this decimal? 5 what? The 5's in what place here? This is the 10th place, the hundredths, and then the what?
Thousandth.
Thousands. This is 5/1000 as an ordinary fraction. Now we can reduce this by 5 and bring it on down to what? We can reduce this down by 5 and bring it down to what equivalent fraction? 1/200? There you go. So 0.5% as an ordinary fraction ultimately is 1/200. Or as an ordinary decimal is just 0.005. Okay. Number 34. Roll this into classwork 1 also. I want you to convert this to a decimal and also to an ordinary fraction. Convert this 12.5% into a decimal and a fraction. Go ahead and do that. Okay, so as a decimal, first of all, you can maybe turn this 12.5% and this mixed number percent into an improper fractional percent. 12 times 2 is 24 plus 1 is 25. So 25 halves percent is another way of saying 12.5%. Then you could turn this into a decimal percent by dividing 25 by 2, in which case you get 12.5%. Now we drop the percent symbol, shift the decimal point 2 places to the left, and we convert it to an ordinary decimal, 0.125. To convert this to a fraction, why not go from decimal form to fractional form? Because we read this as 125 thousandths. So we put 125 over 1,000, and we just keep reducing it down by 5, and we get it all the way down to 1/8. So we have shown ourselves how to convert this mixed number percent ultimately into a decimal and into an ordinary fraction, reduced fraction. Any questions with any of these operations here? Anybody want to see an alternative way of turning 12.5% into a fraction? Anybody?
Yeah,
I showed you this way. I can show you another way though. This way always works too. Change a percent to a fraction, you just literally drop your percent symbol and place the number over 100, because percent means per 100. But this is very awkward to leave your answer looking this way as a fraction. We don't like to leave decimals appearing in any denominator or numerator of a fraction, or that goes for fractions. So Liz, we need to fix this. Okay, well, here's how we fix it. What does this fraction bar suggest? What operation is this suggesting?
division.
Division. So let's rewrite it literally the way we're reading it. It's really saying 12.5 divided by 100, literally. Now, how do we divide a mixed number by a whole number? Change the mixed number first into an improper fraction. 12 times 2 is 24. 24 plus the numerator 1 is 25, and we put 25 over 2. So it comes down to 25 halves divided by 100 then, doesn't it? This 100 can be placed over 1 understood. How do we divide fractions? Oh, we change division to what? Multiplication. And what do we do with our second fraction? We got to flip it, take its reciprocal. Reciprocal of 100 is 1 over 100. And ladies and gentlemen, what do we get it down to now is 25 times 1 is 25. 2 times 100 is 200. And now we just reduce 25 over 200. That looks awfully familiar, doesn't it? So this reduces down to 1/8. That's an alternative way of converting that mixed number percent into a fraction. So the first way I showed you is first to convert the mixed number percent into a decimal, and then convert the decimal into a fraction based on how you read the decimal, and then reduce. Another way to convert a percent to a fraction, this always works, is just placing the number over 100 and dropping your percent symbol. But then you may have to simplify your fraction though. This is very awkward. You don't want to leave it looking like this. That's why we went further and did what we did here, okay? All right. Have I got those two different ways there of converting that a percent to a fraction, ultimately? Two different ways there. I'll let you decide. Obviously, it's up to you as to which way you want to go here. That's why I'm just kind of laying these out on the table, and you can just choose whatever way, you desire. We could try another one like that. 5%. How would we write 5% as a fraction? Well, method 1, ladies and gentlemen. First, I could convert this into a decimal. Drop the percent symbol, shift the decimal point 2 places to the left, in which case it becomes this as a decimal. Now, the way I read this decimal is the way I'm going to set up the fraction. How do we read this decimal? 5 is in what place? The 5's in what place?
Are you writing on something? Because I don't see anything. I don't see your mouse or anything.
What the heck's going on here? I'm sharing my screen. Well. You can't see that at all? Well, hold on. Man, I don't know, maybe I'll have to scroll. I can't scroll down. All right, well, let me show you on my doc cam here, because I don't know what's going on. All right, here's another example. Suppose I give ourselves 5%, and I want us to write it as a fraction. Two ways of doing this. First, you could write the percent as a decimal. How do you change a percent to a decimal? You shift the decimal point 2 places to the left. So it's going to be 0.05. We drop the percent symbol. Now, how do I read this as a decimal? Because the way I read it as a decimal is the way I'm going to write it as a fraction. 5 what? What place is this 5 in? Tenths?
Hundreds.
Hundreds. 5 hundredths. 5 over 100. And now we're going to reduce by 5. And we take it down to 1/20th. There you go. We converted that percent into a fraction. Here's the second way. The second way is to just put 5 over 100 and drop the percent symbol. And now we reduce. Reduce down by 5, we get it down to 1 over 200. Both ways work. So whether you want to go through the decimal form first, then to a fraction, or just go from a percent to a fraction, it's up to you. Okay. Let's try another one here. If I had 6 3/5%, and I want to convert this into a fraction. Method 1. First, I'm going to turn this into an improper fractional percent. 6 times 5 is 30. 30 plus 3 is 33. 33/5%. Then I'm going to get on my calculator and turn this into a decimal percent by dividing 33 by 5. What's 33 divided by 5? 6.6. So this is 6.6%. Now, ladies and gentlemen, we convert this into a decimal by shifting the decimal point 2 places to the left and dropping the percent symbol. That's 0.066. Now we can write this as a fraction, because how do we read this? 66 what? What place is the 6 in? Tenths, hundredths. What place is that? So tenths, hundredths, and thousands. So this is 66 thousandths. Put 66 over 1,000, it's now a fraction. And then we can reduce this down by 2 and take it down to 33 over what? 500. There you go. Method 2, if you don't like this method, how would you convert this into a fraction? Place it over 100. Drop the percent symbol. But then you got to clean this up. You don't want to leave it looking that way. So this is to be thought of as 6 3/5 divided by 100. That's what it's really saying. Turn this into an improper fraction. 6 times 5 is 30 plus 3 is 33. 33/5 divided by 100. Or 100 over 1. But ladies and gentlemen, we changed, how do we divide fractions? We change division to multiplication and multiply by the what? Reciprocal. So what's the reciprocal of 100 over 1? 1 over 100? Now we have 33 times 1 is 33. 5 times 100 is 500. Recognize it? Deja vu? Same answer. So to go from a percent to a fraction, whether you want to go through decimal form first, or whether you just want to place the number over 100, drop the percent symbol, and then wrestle with it thereafter. It's up to you. Okay? Both ways work. How would I convert this percent into a fraction? Again, there's 2 ways. Method number 1. First of all, turn this decimal percent into an ordinary decimal by shifting the decimal point 2 places to the left. So this is going to be 0.0605. Now to go to a fraction, we write it the way we read it. This is 605 what? Tenths, hundredths, thousandths, 10,000ths. So this is going to be 605 10,000ths, 605 over 10,000. And now we just reduce. This reduces down by 5. Let's see here, what does that reduce down to? 121. Yeah, 121, right? And this goes down to what, 2,000? And this cannot be reduced anymore. Second way, how do you convert this decimal percent into a fraction? Well, place it over 100, the number over 100, drop the percent symbol. But this is very awkward to leave this looking this way. Don't want to leave this way. So I got to make this numerator become a whole number. To do that, I would have to shift its decimal point 2 places to the right. But if I shift the decimal point in the numerator 2 places to the right to maintain an equivalent fraction, I must also shift the decimal point 2 places to the right in the denominator. Got to add 2 zeros. So this is really equivalent to 605 over, got to add 2 zeros at the end here. Over our friend 10,000, which is really 121 over 2,000. Same answer. Okay. So now I showed you 2 different ways of converting a decimal percent into a fraction. First by going through decimal form, and then writing the decimal as a fraction and reducing. Or you can just place the number over 100 and then wrestle with it and clean it up as a fraction. 2 different ways. I'll let you decide which way you're going to go. All right, let's move on here. Let's get into some word problems here. All right, ladies and gentlemen, I want you to do number 41. The diamond ring was reduced from $999.99 all the way down to $399.99. I want you to compute the percent decrease or the percent reduction in this price. So what percent decrease does this represent? Number 41. Just add it into classwork 1. 41. All right, my formula, take the big number minus the small number, that represents the amount of decrease, and divide the amount of decrease by the original number, which is $999.99. And then you multiply this by 100% and you get 60% reduction. Anybody get that? 60% reduction. So my formula works like that one. Big number minus small number divided by original number times 100%. Always computes percent increase or decrease. Anybody get that? Anybody? Are we getting this? Is making any sense?
I did.
I do.
60% reduction. All right. See if we can move on. This is still part of classwork 1 we're working with. You know, in reality, I don't really care if you call it classwork 1 or classwork 1,000,001. Bottom line is I'd like you to send in what I just said be due for classwork. Okay? Let's see what else we got here. Let's see. All right, ladies and gentlemen, we're gonna try problem 45. This problem is gonna be done in 2 stages. First, you're gonna have to take the 40% off of the original price, and then you're gonna apply a 20% off, additional off of your new price after taking 40% off to give us our final price. All right, so not including sales tax, what are we going to bring to the register here? Okay, how much are we gonna be charged at the register minus the sales tax? All right, go ahead and do 45. Still part of classwork. All right, so the luggage originally retails for $159.99, but there's a 40% off sale. So the discount is the amount of money that's taken off the original price, is going to be 40% of $159.99. So 0.40 times this, the original price is $64 discount. We're therefore going to subtract $64 from our original retail price, $159.99, and therefore the sale price is $95.99. But we have a 20% off coupon. We're going to present at the register, and they're going to take an extra 20% off of our sale price. So what amount of discounts knocked off the sale price? That's 20% of the sale price. 0.20 times the sale price, $19.20. Therefore, the final price will be the sale price minus the $19.20, which is $76.79. That's the final price we're going to pay at the register, minus sales tax. They're also going to slap on an extra, so much percentage of sales tax onto this. But anybody get that there? $76.79. So I worked the problem in 2 stages, as you can see. Anybody get that?
I got 7680.80.
All right, don't worry about that. There was a slight round off thing with a thousandths digit, I think, with the first computation. So I'm not concerned with that. All righty. In general, does this make sense what we're doing here? All right. And I would assume Alex would allow you that wiggle room between calling it 79 cents versus 80 cents, as they should. All right, because there is a little bit of an issue where I think the monetary value goes out to the thousands here, and you got a bunch of nines, and I bumped it up to $64. Okay, for the first discount there. All right. All right, next problem. Number 48. Do this one next. We'll just all call this all part of the classwork we've been doing, okay? So you can call it any classwork you want, but all the ones I want you to do, just send them in. So number 48, go ahead and do that problem involving commission. All right, so commission is equal to the commission rate times the amount of sale. The commission rate is 12%. The amount of sale was a $2,499.99 TV, I believe. 12% of that sale amount is, I rounded it up to nearest dollar. I think it's like 0.998 or something. I'm gonna call that $300. Anybody get that?
Yes.
All right. Now let's try another one here. These are kind of fun. Let's try number 50. Roll that into your classwork. Number 50. Go ahead and do.
You're still muted.
Sorry about that, Lizzo. But did anybody get $101.76 for the cost of the item at the register after the sales tax assessment? So for every dollar we buy, that's subject to sales tax, the government gets 6 cents for every 100 cents we spend on probably a non-food item. All right, anybody get that?
I did.
All right, these problems are really not that bad. About number 59, try this one. See if we can become a wise shopper. Number 59. Go ahead and do that one. It looks like the 25% off sale is gonna save us some more money. 25% off $129 is gonna be $129 minus 0.25 times 129. Takes us down to our final price is $96.75. You knock off just $20 off of 129, you still gotta pay 109. So it looks like 25% off sale saves us $12.25. Anybody compute that?
Yeah, I got that.
This is called the discount. Discount rate times the amount of sale or the cost of the item. Take the discount away from the original price, you have the sale price. Okay. All right. Okay, so we are becoming wise as a shopper. All right. Okay. All right, so ladies and gentlemen, what we worked with today is we worked with percents. We seen how to go back and forth between a percent, decimal, and fraction. And then we started working with some word problems here. Some of our word problems wanted us to compute a percent increase or decrease. And I did give you a nice formula for doing that. I handle any one of those. So you can call this a percent change formula in general, if you will. Big number, always minus the small number, divided by the original number. And you multiply this by 100%. Okay. All righty. You know, back in the 1980s, I can remember buying a brand new car battery for $65. It was brand new. That same battery today retails for $214. I want you to compute the percent increase in the cost of that battery over that time period. Go ahead and do that. This will be part of classwork too. Just throw this in there, classwork. What's the percent increase? Well, anybody get that? This battery has increased by 229%. Anybody compute that? Now the amount of increase is $149. The percent increase is 229%. Anybody compute that? Just make sure you enclose your numerator inside parentheses here. If you use your calculator, Before you do the division, otherwise your calculator is just gonna divide this number by this and subtract it off from that. That's not what you wanted to do. You're gonna get a logical error, okay? Anybody else get 229% increase? All right, ladies and gentlemen, you have a great weekend. I'm gonna open up the chapter exam. 5 and 6 exam. I'll get that going and get that up and running.